So I'm picking up another thought, again using this organic molecule of the day, the 2-bromo-3-methyl pentane, and saying that, proposing to you that on its own, without provocation, this alkyl halide might ionize. And what would happen in this possible scenario is that bromide separates from the organic molecule. We're left with a carbocation on a secondary carbocation. Now, I explained to you in an earlier video that it is likely and very likely and very quickly, a hydride shift would move the carbocation, effectively move the carbocation from a secondary carbon to a tertiary carbon. That would happen by an invisible, but you know it is there, hydride shift. And H with a pair of electrons, if it migrates next door, the result is that the carbocation resides on the tertiary carbocation. Now, we have to consider 4 possibilities of what might happen. If we have a chemical species, I'll use what I've used before, methanol, which is not a strong base and not a strong nucleophile. It is exactly a weak base or a weak nucleophile. It might act as either. In the first case, and I'll write this, if methanol acts as nucleophile, then it attacks, it forms a bond to that carbon. We have, and now, let's say, OCH3 protonated, and this rather quickly, because the organic molecule doesn't really want an extra proton in the solvent that's banging around, we'll take it off its hands. We have OCH3. We'd have a nucleophilic substitution product. But there's another possibility. Again, even with the same conditions. So let me erase this if condition and say, if methanol acts as a base, now I want you to keep in mind that a base is a chemical species that can accept a proton. So if methanol, because it has these unshared pairs of electrons, which is a good landing site for a proton, if, I'll draw this in now, let's consider hydrogens on a carbon one bond away from the positively charged carbocation, from the positively charged carbon, if the base grabs that proton, a proton, but left its pair of electrons of it there, the product of that reaction, the product of those 2 curved arrows would be this. Now a double bond between carbons 2 and 3, and the second product would be CH3OH. Protonated methanol, the methanol acted as a base and it grabbed a proton. The product is an alkene. Now there's another, let me explain. If all of these events happen, if the 2-bromo-3-methylpentane spontaneously lost to bromide, produced a secondary carbocation, the secondary carbocation rearranged to be a tertiary carbocation, and if in the presence of even a weak base, if the carbocation lost a proton from a carbon adjacent to the carbocation, an alkene was formed. We would say the overall effect of this is that H and Br have been lost, have been eliminated from the organic molecule. An H from that position and a Br from that position have been lost from the organic molecule. It's an elimination reaction. This elimination reaction happened in a two-step process. The rate-determining step, the loss of bromide, is a slow step. The rate-determining step, that involved only one chemical species, so all of this would be characterized as an E1 elimination process. I have another elimination reaction to show you under slightly different conditions. In this case, we've got the same alkyl halide, a secondary alkyl halide, 2-bromo-3-methylpentane, but in the presence of a methoxide. Now, a methoxide is both a strong nucleophile and a strong base. It's good at forming a bond to a carbon, or it's also good at abstracting a proton. Now, if we're going to specify that in this case, under present consideration, the methoxide acts as a base, as a strong base. Now, if this strong base encounters an alkyl halide, it will notice, and I'll draw them in here, that there are a couple of protons that are attractive in the view of the base. Good for stealing. The base says, oh, I could steal that. Now, an event that I'll represent, I'll use another color, I'll represent by the attack of, if the methoxide looks at one of the protons on carbon 1, says, I'll take that proton and liberate that pair of electrons to form a pi bond between carbons 1 and 2 and displace bromide if those three curved arrows happen in one event. The product would be this. The same carbon framework, but now there would be a double bond between carbons 1 and 2. Now there is a second possibility that I'm going to show you now. I'll need to erase for a second and say, what if the base attacked a different proton? Now there's another possibility. That's what really does make this rather a complicated subject. What if the methoxide acting as a strong base chose to go for, use my green for this, chose to go for that proton. If that happened, that pair of electrons would be free to form a bond, funny looking arrow, but there it is, to form a pi bond between carbons 2 and 3. If that happened, the product would be it would be 3-bromo-pent-2-ene. The pi bond would be internal. The pi bond would be between carbons 2 and 3 of the alkene. The second product would be, it's a blue product, it turns out, CH3OH. In this case, the H and Br are eliminated from H and the Br are eliminated from the organic molecule. We have an elimination product, but the events happened in one step. There were two chemical species active in the rate determining step. It would be an E2 elimination reaction.